So I started a new project yesterday. It's pretty complex, so hold on to your hats. It is this. It's not complex at all. We've just got a CR2032 powering some LEDs. And I need to do a bit of an experiment to find out if this is going to work, because I don't know if it can drive that many LEDs. I don't know what the current draw capability of the CR2032 is. I know that the internal resistance of the battery will limit it somewhat, but I don't know to what degree. So we're going to breadboard something up. But the interesting thing about this is that I'm turning it into, it's not a badge. It's more of an ornament, I guess. Now, I saw someone's social media profile photo and they had "Don't Panic." Now, it's not "Don't Panic" from Dad's Army. Don't panic! Don't panic! But it is "Don't Panic" from Hitchhiker's Guide to the Galaxy. And I can probably show you this if I just switch to the bottom layer. It probably looks a bit better. So what we've got essentially is "Don't Panic" using sort of the T-stop and keep out areas on here, so that we've got gold around the outside. Well, I'm going to use that Enig process thing and have gold put on there. But essentially we've just got copper around the outside of these letters as a stroke, and on the inside it's see-through. Well, not see-through, is it? It's just going to be the F44 material so that we can light some LEDs. Now, I've positioned them on the outside of the letters. I don't know how well this is going to work. It may work okay, we'll see. I've never done this before. They're going to be side mounted so that they shine up. Now, some of the letters like this I here only have the one LED because there isn't space to put another one. These are 0603 LEDs. 0603 LEDs, yeah. And the resistors are also 0603. Although they look massive. Yeah, they are 0603. It's just a different footprint, I guess. This is hopefully what it's going to look like when it's fabricated. I don't know if I'm going to use PCBs.io, but they have a nice preview service where you upload your file and you get to see what it's going to look like. So it looks darn cool like this. Now, I haven't put anything on here to make this flash or anything like that. What I have got is some space up here. So we might want to do like an A-stable multi-vibrator with a couple of 2N3904s. In fact, we did that. Remember that lighthouse thing that I made? That kit from, I don't remember who, someone got it for me. They were really annoyed about it. It might have been Steve, not sure. Anyway, I rigged up a quick 2N3904 flasher doing that. So we might be able to do that with this board. We'll come back to that though, because I think we'd have to separate out the power because it's currently all connected. If we wanted maybe to have "Don't Panic" flash like after each other, so "Don't" on and then "Panic" on and "Don't" on, "Panic" on, and that kind of thing maybe. I'm using a weird battery thing. I'll show you what that is. Let's go over to the breadboard. Actually, just before we continue, let me just show you how to import a BMP into Eagle so that it's not a complete waste of time, this whole video. So we'll see. Right, so if we go to File, Import, Bitmap, then this text comes up. You can ignore all of this. Now it'll ask you to select a file, so I'm just going to go to the desktop where I have a couple of them. So I've got "Don't Panic White BMP" and "Don't Panic BMP." So let's have a look at those. So this is "Don't Panic White," and so that is the black outline which goes around the letters, so it's like a stroke. And this one is just "Don't Panic," and that is the inside of the letters. Now, I pulled that off here. I used a font that looks fairly similar to this. This is Gerald42's profile picture. So thanks, Gerald. Anyway, so I recreated it in Photoshop and did it this way. I also made an SVG version and tried to import that, but it didn't work very well. Sometimes SVGs end up looking really strange. So I even went to the effort of... So this is an SVG of "Don't Panic." I even went to the effort of cutting holes through them so that it would have appropriate points on it. So you can see that it's cut through there, but this still didn't work in Eagle. So anyway, we're going to import one of them. Let's import "Don't Panic." So it's going to ask you about colors used in the bitmap, and I'm pretty sure I only want to bring in the black. So the white ones I'm not bothered about. So if we clear everything, select the black, click OK, and then it's going to ask us about scaling. So our scale factor for a pixel, I'm going to go with 3 here because that's what I've done on these to make them large enough. And then you choose the layer. So let's choose layer 1 and click on OK. So what I did for these other ones is choose layers which meant the keep out layer or the restrict layer or just the top layer for the bare copper, and then a keep out section on that as well. So just click OK, and it's generated this script. So we'll click run, and then somewhere down here we might have to move our viewpoint when it's finished doing it. It's going to bring in that text. Now what it's done is mapped pixels to lines, to little signal lines, right? So little, not signal lines, little rectangles, and it's just drawn it out like a printer would do, which is fairly awesome, isn't it? So that's on the top layer there. We don't want that, so we're going to select it all and delete it. Right, back to the breadboard. So before we go any further, we need to do a little calculation. Now, I'm not one for maths, we've spoken about this before, but we do need to do a quick calculation, and it's not a very difficult one, it's a really easy one. So first off, we need to figure out what our voltage is. I've got a CR2032 here, and that's 3.22. So let's just write this stuff down. So our voltage is 3.22. I could have put the voltage on the other side, never mind. And then we need to figure out our forward voltage on our LED. So this is a bit of a guess. It doesn't matter. I'm just proving current on these CR2032s. So forward voltage on this diode is wrong way around. No, it's definitely this way around. I don't think it can read it. I think we'll go with it's lighting the LED. It's just not giving me a reading. I'm going to go with 2.2. So 2.2 volts. So forward voltage is 2.2 volts. That's a little bit of a guess. And we want to get 40 milliamps because I think with that many LEDs, 40 milliamps seems like a reasonable, well, it's a lot, isn't it? But let's say I've got 18 LEDs and they're pulling about 2 milliamps, which is what it will be with the 470 ohm resistors. So we'll go with 40 milliamps. So our current, the I thing, equals 0.0, is it 0.4? Yeah, 0.4. And then we have to do a calculation. So we do voltage minus our forward voltage divided by our current, and then I'm going to do it on a calculator because I can't work any of this out. So let's see, we want 3.22 minus 2.2 equals 1.02 divided by 0.04 equals 25.5 ohms. So 25.5 ohms. So we're using that Ohm's law thingy, which I did have to look up, to be honest. So just before I started the video, I went to make sure that I knew how to do it. Anyway, so we need a resistor that's 25.5 ohms to throw into our LED. Now, I've got something else to show you as well, but we'll first find our resistor in this big bunch of stuff. I'll skip this bit because it will take a while. Right, I've got some 22 ohms, so that will do. Now we need a breadboard. Now the thing about breadboards is I've got quite a few. Oh, by the way, I remembered who it was that had the Don't Panic profile photo, and it was Gerald42 who commented on the last video I did. And this breadboard bit is actually in reference to someone else on YouTube who I was watching a video of his the other day, and he was sort of bemoaning that there are only 5 blooming columns on a breadboard like this one. So it's only got 5 columns here, or rows. I don't know, what would you call them, rows? Yeah, those are rows and those are columns, I guess, because the letters go down. But there are only 5 rows per side. And that's the same on most breadboards. So it's the same on this crappy, crusty old one. It's the same on this one. It's the same on this one. But it's not the same on this one. So they're all a little crusty. This one has 6. In fact, let's turn it around the right way so that you can see the letters. So we've got A to F and G to I, as opposed to this one, which is A to E, F to J. Oh, L, that one was over there, I misread it. Anyway, so this is a different kind of breadboard. And I went off to eBay and picked up another one. So I mentioned this to James in the comment on his video to say you can actually get these 6-row boards, and this is one of them. And it's from Maplin, believe it or not. So yeah, this is the breadboard AD102. Now it's got power rails on top and the bottom, and it's got 456 tie points. So let's get it out. This Maplin is no longer around. So you're buying these off eBay secondhand if you're getting them at all. Oh, we've got some, so 6 pin groups, 12 pin groups, 4. So it's basically just got split down the middle, hasn't it? So this is the breadboard. It's quite nice actually, but you can see that we've got A to F and G to K. What? H-I-J-K-L. Oh, of course it's L. It's in the bloody alphabet. Okay, you can add letters to another thing that I'm not very good at. Anyway, we'll use this breadboard. Oh wait, there is another breadboard that I've got. This one's an interesting one actually, so we're gonna have to come out quite wide for this. I actually got it out to show you, but I forgot this one also only has the 5 rows, but it is a Protoboard 203A. It has a built-in power supply. Gosh, it makes a horrible noise. In fact, I can show you. Let's bring this in. I don't know whether you'll be able to see the values on there. Yeah, you can. Good enough, at least. Oh, wrong way around. So we've got 4.97. This one should be 15 volts. It's 13.6. There is a trimmer inside where you can adjust these. And this is our minus 15 volt rail, which is reading -2. But if I stick that into 15 volts, we've got minus 15. So it's quite cool. It was being thrown out, so I happily took it in. We might have a look inside this one day. And the reason being that it generates 5 volts using a 7805, but it also generates 15 volts using a 7805. And minus 15 volts using a 7805 with a clever little bit of circuitry in there that I'd never seen before. So we might have a look at that at some point. It's quite crusty and horrible. Well, that's embarrassing. Don't assume the forward voltage drop of a diode. It's actually, I've got a little bit of, where is it? Oh, it's here. The packet that these are stored in, you can't read it because it's so worn away, but it says forward voltage is 3 to 3.2 volts. So making some assumptions there. So let's recalculate this. In fact, we'll just use a different LED, but at, well, it just won't work, will it? It would need a lot lower resistor. So we're going to just choose something else. So this LED here, we can check its forward voltage. So let's give that a go instead. Clever Dick Watts. So this one has a forward voltage drop of 1.8 volts. So if we throw that in our circuit, and what was our previous calculation? We put a forward voltage of 2.2. So there's our LED. Now, according to my power supply, it is drawing 23 milliamps. So we've got about 38 milliamps being drawn there from a 3 volt power source. So let's try it now with the little cell and see if we can do it. So we probably want to run this through our multimeter again, just so we can preview this. No, we are not going to get that much current out of this little battery, you can see it just drop. Now this is the Just CR2032. It might not be a fresh cell, so maybe I'll grab another one. These aren't by any means premium cells, so I do not know how good they'll be. .3. Now there is going to be a little bit of a voltage drop on here, so just have to bear that in mind. We are getting 32 milliamps out, so the internal resistance of this battery is stopping it from drawing too much. And it's dropping fairly dramatically, so perhaps we'll have to rethink how we power those LEDs. They're going to be red LEDs, so I'll figure out the forward voltage drop on those. But currently I've just designed it with 470 ohm resistor. So hopefully you found that mildly interesting. Turns out the internal resistance of these ones, these specific ones, I can certainly use something like an LIR 2032. They can kick out a bit more current, but they'll still be limited. So that thing over there might have to have a few design changes made, because not quite sure I can run all of those LEDs. But I mean, there's a lot of letters. It needs some for it. So any ideas would be welcome. But yeah, it's going to be a fun one, isn't it? I do enjoy doing stuff like this. All right, I'll speak to you all soon.